Thanks for coming to the fourth talk in the design track. I have the privilege again, because I have to choose. I get to choose the speakers. To introduce the man, the myth, the legend. I had no clue what his title was, because I always just thought his title was Arseny. So that's how I'm going to introduce him. It's Arseny, title Arseny.
All right. Hello, everyone. It's great to be here. It's great to see all of you. Good party last night. And it's really fantastic to see a lot of familiar faces, but also a lot of new faces. So my name's Arseny. My username is ZooxCG. If you ever wondered how to pronounce this, this is good enough. And I'm a technical director at Roblox. And I work with a lot of teams that work on game engine and studio and different parts of the product. And I want to talk to you today about performance. So what are we going to talk about today? So why should you care about things that I will going to tell you about, namely memory and performance? What kind of tools do we have to help you figure out, is your game performing well, and why is it not performing well? New features that we have introduced to help you optimize your game, and a bit of a deep dive into various areas, rendering, physics, scripting, and kind of performance cliffs that can expect you there, what you can do about this. I will try to balance this between being too technical and not technical enough. Let me know afterwards how we did, and maybe next year we can do a better job either way. So memory and performance, what is memory? Memory is number of bytes used by your game to store basically everything that you have. So it's objects like parts, string values, et cetera, It's textures, it's meshes, it's Lua tables, and any other Lua objects you might allocate in your script. It's like everything, right? So we typically measure it in megabytes, which is 1 million bytes, more or less. And your allowance varies between the device and the platform, but typically it's hundreds of megabytes on mobile, low hundreds to high hundreds depending on the device, sometimes 100 singular. So why is this important? Why is memory important? So if you don't fit into the memory budget, your game crashes on device. When your game crashes on device, we know that it often crashes on devices of a certain type, and we stop showing your game in sorts. Thankfully, you have visibility into this on the developer stats per game, I think. And this is one of the biggest issues that developers face on mobile, right? Like if your game has to run on mobile, it has to fit in the memory budget. So we currently have good breakdown for iOS devices. The breakdown for Android devices is a bit lackluster, but we are improving that. But in general, this is kind of your go-to to see, hey, do you even have a problem? Maybe your game is working great. And we call it filtered devices because your game is filtered from sorts if it doesn't fit. So the second dimension, I suppose, of performance is join time, which is how much time does it take for a player to join the game. They click the play button, they wait for 5 seconds, 10 seconds, 20 seconds, like a minute, whatever the case might be, and then they can play the game. There's no real allowance here, right? You're testing the user's patience. We typically think of this as you want to get it as low as possible. The average, or the median rather, across desktop and mobile is around 5 seconds. If you're over 10 seconds, then it's not great. If you're like a minute, then it's probably really bad, right? And ideally, you would measure this time up until the interactive state in your game, right? So if you have a loading screen, it helps because it helps the user not give up immediately. But ideally, you would measure the loading screen's time as well. And then finally, the frame time, what is more traditionally, I suppose, thought of as performance, right, which is how quickly does your game run. So you can measure this in frames per second. The more scientific engineering measurement is to measure a frame time in milliseconds or seconds, but seconds is too long. So measured in milliseconds, the allowance is 15 to 30 milliseconds per frame. This corresponds to 60 to 30 FPS. And the crucial thing to know here is there's two important factors. One is what's your average. The other one's what's your maximum. So you can have a game that runs at 15 milliseconds per frame, so 60 FPS, rock solid. And then every second, there's a frame that takes like half a second. And this is a really, really jarring experience. And this is way worse than just running your entire game at like 30 milliseconds per frame. All right, so there's these three different dimensions of performance. what do you do with them? How do you know if your game is fast or slow or how much memory it takes? Well, the answer is you have to measure every single thing, right? So if you want to know if you have a memory problem, the filtering device list is a good sort of proxy, but the more powerful instrument is actually knowing how much memory does your game take. So let's look at all of the tools that we have available for this right now. So one is performance stats. So this is a widget that shows you the general breakdown. Hey, what is my frame time? What's my memory consumption, et cetera, et cetera, et cetera. And this is meant as a high-level overview that says, am I doing OK, right? So this is available on all platforms. On desktop, you can use Control F7 to enable this. On mobile, it's available in settings, and on other platforms, it's available through settings. This is good. This is not good at diagnosing why the problem happens, but it's good at answering the question of, do you even need to fix anything, right? So if your CPU graph is like it is in this picture where there's a red spike in the middle, this means, hey, you had a frame spike. So the frame was too long. So this is not great. If it's nice and smooth and green, then it's all good. You don't have to worry. So then, digging in deeper, how do you look at each individual axis? So for memory, we have, as part of the developer console, a breakdown for client and server memory. And this is based on the categories, and these categories are described on the wiki and should be described on DevHub by now. And they tell you for each type of object how much memory are all objects of that type or all memory of that category, how much is it using, right? It's available on both client and servers, so we'll be talking mostly about the client parts here, but the server is also important because for those of you who have really big games, you can also run out of server memory and crash the server, and then the entire game goes down, and then 30, 40, 100 people, however many have played, are disconnected. So this is also not great, right? So this is available for both client and the server. For the server, you have to be the game owner. You have to be in the group to see this data. Crucially, some of these categories are the same between different devices. Some of these are different. So in some cases, the memory consumption for textures may be smaller on mobile, but still large. And Studio might not show you the accurate view, and Player might not show you an accurate view. So ideally, you should look at this per device. So if you are optimizing for mobile, get a mobile phone, look at the behavior there. So going back to frame time, the most powerful tool that we have right now, and as far as I know, a lot of devs use this, is Microprofiler. So this is kind of how it looks. It shows you a precise measurements of every large step that happened that was required to simulate or render or whatever the case might be of your frame. The cool thing here is it shows you an insight both in the engine, as in what components of the engine are slow, but also on your code. Oh, you have a script that's running that takes a lot of time. You can customize the view that you see for your scripts. We have this debug.profileBegin-end macros. And it's available on desktop and mobile, not available on consoles right now. So on desktop, it's Control F6 to bring up the view. And then you can press Control P to pause this. On mobile, this is recent. Many of you probably don't know this. This is now available on mobile. You can enable this in Settings Microprofiler. Because of how mobile works in terms of screen real estate, et cetera, you need an extra computer to actually see the results, right? Not extra computer, but whatever computer you're using for development. And we have documentation about how to enable all of this on the wiki. And this is really crucial to understanding why your game is slow, why is the frame time too large? All right, so when talking about join time, unfortunately, the best tool available for measuring join time and understanding join time is a stopwatch. So you just, clock the time. I press play, I'm in the game. OK, this was 5 seconds, I'm doing OK, right? Fortunately, when you ask why does my game take too long to load, usually the answer is you have too many instances, you have too many voxels. Basically, your game is too large, you are not using streaming, et cetera, right? So it's less nuanced than performance or memory, than frame time or memory, but we don't have better tools yet. We might in the future. The big thing to note here is, so I was talking about the loading time as getting to the interactive state, right? So this includes spawning a character, et cetera. Watch out for some cases where the server has to process the loading of the player or the player's character, and this can take a while. There's an interesting example where one of the games that launched, one of the popular games that launched a while back, was using a third-party analytics service, and due to a coding error, their analytics code was not completely asynchronous. It was blocking the calling code, and they had the analytics code in their character loading path. So this was great, works great in testing. You start your game, the character spawns, it dispatches an analytic request to your third-party analytics service. It's all good. Then you go live, you get 15,000 concurrent players. Your analytics service goes down, of course, and then all of the analytics requests on the server start timing out. And then the players have to wait for 30 seconds for your analytics code on the server to time out before actually playing the game. So this can happen, right? And it's important to think about this when you work on your game. How can I minimize the delay between the player click and play and actually being able to play? All right, so let's talk about the new features that help with all of these different axes and dimensions. Some of them have been covered in the keynote. Some of them might not have been. The key thing to understand here is both you and we share a responsibility of performance. We have to work on making the engine faster and support more use cases with smaller memory impact, etc. You have to work on understanding why your game is slow, sometimes optimizing your content, sometimes telling us, hey, you have the system. I thought your engine is supposed to be fast. It's really slow in this particular case. Why? And oftentimes, we can't anticipate everything, and oftentimes, we can't fix something if you tell us about this. If you never tell us about something, we will never fix it. So you have to drive the process. You have to tell us, hey, why is this thing slow? Sometimes the answer will be you have to change the content. Oftentimes, the answer will be, OK, we can try to fix this on our end. So let's talk about the new features. I'll go a bit in detail. So instancing has been covered in Keynote. Roughly what it does is it's a new system that is meant to render parts of any type. We have this old rendering pipeline that a lot of you know as featherweight parts. It was shipped in 2012. This is one of the first things that I worked on at Roblox. It was a really great solution at the time. What it does is it takes objects that are really close together and merges them dynamically into larger objects to be able to render them more efficiently. So this is amazing for performance when nothing changes. There's two problems with this. First, if you have a lot of mesh parts, for example, or other parts with a lot of triangles, then this merging process can take a lot of time. And this is called reclustering. And you might have seen us refer to this on Dev Forum in various cases. And the other problem is the memory cost of the 10 mesh parts is now 10 times the memory cost of one mesh part because we have to merge all of them together, right? So this is not great. This causes performance problems. This is the best solution available for really low-end devices. However, we are starting to deploy a new solution which is using more GPU features and removes a lot of these problems. So mesh parts don't take the memory cost as proportionate to the number of clones of each mesh part. So if you take traffic cone and instance it 10 times, just clone it 10 times, it's the same memory cost, roughly speaking, as one. And updates become much faster. So you no longer have these spikes in frame time where, oh, hey, this object changed color. Suddenly you have to rebuild part of the world around it, and this takes time and makes your frames longer. So the good news is you almost don't have to do anything to enable this. The bad news is it's not available everywhere yet. So right now, it's deployed for all mesh parts and CSG parts on most of the platforms for most of the users. The only exception is Android, where it's on for only about 20% of the devices. And we are trying to enhance the sort of support for this. It's just a bit painful because we are facing graphics driver issues and whatnot, but we will work through this, right? And it's only available for CSG and mesh parts right now. We have an update in works that is almost perfect now, and it will apply to basically all part types with two major exceptions that are important to be aware of. One exception is the new part instancing system does not support outlines for a variety of reasons. As far as I know, most people just don't use outlines, so this is all good. If you happen to have lighting outlines enabled, but you don't actually care about outlines, disable it. It will be faster. And then the other thing is currently the part instancing system doesn't support humanoids, so the humanoids go through the old path, right? So, I mean, you should still be using humanoids for characters, but don't use humanoids for random objects in your level because you want them to cast shadows or something like this. That will be solved by Future is Bright eventually. So level of detail. So we have two kinds of plans for level of detail. One is short-term, one is long-term. The short-term is, should ship this year, is what Adam covered in the keynote, automatic mesh and CSG simplification. You will have controls to be able to disable this. It will be probably on by default, but if you have an object that's like really gameplay critical, has to stay in the exact same shape, you'll be able to disable this. It's similar to collision fidelity. Long term, though, we kind of want to enable a more complex use case where you have a house that's built out of 1,000 parts. Right now, this house can be available on the client as 1,000 parts. Also, if you enable streaming, the streaming system can decide, hey, just like remove house from memory. So there's this binary state. What we want to have is we want to have a system that also allows to automatically say this house that contains 1,000 parts can be simplified automatically to a small mesh dynamically. And then the server will send you a mesh. If this object is far away, you will still see the house. You will not be able to interact with the house, but it's far away, so it doesn't matter. So it's kind of like a streaming LOD solution that we are thinking of right now. It will happen later, not this year. So the other big thing that we are starting to roll out, we did a beta test a few days ago. It's disabled for now, but it'll be coming back, is texture transcoding. So a lot of people aren't aware of the memory cost that their textures take. So let's take a 1024 by 1024 texture. The 1024 by 1024 texture in Roblox eats 5 megabytes of memory. It doesn't matter what you put in your texture. It doesn't matter what format you upload it in. It's 5 megabytes. So you may look at the PNG size and say, hey, my PNG is 100K. It does not matter. The PNG is not stored as a PNG in memory on device. So the problem is there's a lot of memory burned by all of this. And there is a better solution available on many devices, which is hardware-specific formats. So what will happen is that when you upload this texture, we will automatically, on our backend, encode into various formats. And they will take less memory on mobile. And then on mobile, we will choose these versions to render instead. They will be slightly lower quality. We are thinking about two things. One is, do we need to allow you guys to say, hey, I want this particular texture to always look perfect on any device, no matter what. Don't touch it. And the other thing is, when you testing in studio, you're running on PC, but you kind of want to know what does my game look like on a phone, right? So it's not there yet, but we want to enable the support in the studio emulator for this as well. So this will be coming really soon this year. So the other big thing is we are doing a lot of work on UI performance. So Adam mentioned UI input optimizations in the keynote. There's one other major piece that we are doing that has to do with UI updates behind the scenes that will ship this year. And there's a third thing that will ship this year, which is UI caching. So the current solution for rendering UI is whatever UI you have on screen has to be processed every frame to render it. It's kind of a legacy. We focused a lot on 3D performance and less so on UI performance over the years. So this is the state that's in. This means that if you have a lot of surface GUIs, they tax your frame rate. If you have a lot of 2D UI and it's visible, it taxes your frame rate. So we plan to move to a solution where if you don't update an individual UI container, then it basically is almost zero cost to render it, right? And the initial thought is that the granularity of this caching will be the screen GUI or surface GUI or billboard GUI objects. The reason I bring this up is a lot of people put all of their UI in one screen GUI. With the system, it's less efficient to do so because any change in any UI element will get you back on the slow path, which is the current path, right? So your game won't run slower than it does today, but it will not run as fast as possible. So you should really split your UI, your on-screen UI, into screen GUIs based on the domain frequency of changes. Like if you have a HUD and player list and chat and shop button and something else, just split them into separate screen GUI elements based on whether you expect this to change every frame or not, or just based on semantics. All right, so we covered most major features that will ship or are shipped in some form that have to do with performance. Now let's do a bit of a deep dive and try to understand some of the aspects of performance a bit better. So let's talk about scripting first. There's three kind of crucial questions when you write low code that you have to answer for yourself. The first is, when does your low code run? The second is your low code efficient, like are you using the Lua engine efficiently? And the third is, are you utilizing Roblox APIs well? So let's go over these quickly. So when do I run Lua code? Well, the natural solution is let's just run everything on render step, because render step runs every frame. My code will run every frame. Great. So no. What you need to think about is, do you need to run the code every frame? If you do need to run the code every frame, there's various options, but ideally you don't. So you should prefer event-based code. A user presses a button, and you run some code that launches an animation. There's no need for every frame to ask, has the user pressed the button in this frame, right? It's less efficient. If you have something that can run at less than real time, like at 10 times per second to 1 time per second, then don't run it every frame, right? The caveat there, though, is that if you have a long-running process, for example, you're saying, hey, I have this update of my AI. My update of AI takes 100 milliseconds, so if I run it every frame, my game runs at 10 FPS. Awesome, I will run it once a second, so my average frame time is now back to normal. Well, so the problem is once a second you have this frame that has 100 milliseconds of work. So if you have long-running code, beware, right? So frame spikes are a problem. When you have long-running code, try to slice it into small pieces and so that you can run each piece every frame without taxing the overall performance. Use Microprofiler to tell you, is the code even slow, how often does it run, et cetera, et cetera, et cetera. There is some old misconceptions. I'm not sure if the text is readable. It's OK. There are some old misconceptions about various signals that we have in the engine, and we changed the approach over time. And some people think that stepped is somehow really different from heartbeat or render stepped because some of them run at like 30 times a second. Well, no, this is all not true. They all run every frame. The only big difference is in ordering, like stepped runs before physics simulation, heartbeat runs after. And render stepped is crucial. So on this diagram, you see the timeline of 2 frames. And the render code mostly runs on a separate thread, except for render stepped, which means that if you run code in render stepped, you're inflating the time that it takes us to render a frame, essentially, right? And you could be running your code in heartbeat or stepped, and it could be free to run this code if the rendering of the scene is really complex. There is some coverage of this on the forum, and feel free to ask me about things like this later if you want more details. So I'm not going to go into too much detail on Lua, because thankfully a lot of the Lua details that we have are very similar to the classical Lua details. Like any Lua code runs, has the same sort of performance pitfalls. Creating objects might be slow. Accessing properties might be slow, because every time you do so, you have to go from Lua to our engine and back. Calling methods can be slower than not calling methods, etc. So there is good documentation online. There's low performance tips by, I can't pronounce his last name, but he was one of the authors of Lua. And the documentation for this generally is applicable to Roblox. The only caveat in Roblox is if you don't have to query a property, for example, like 10 times in a function and can do it once, please do so. It will be much faster. It's easy to miss this when just writing code and not thinking about performance. So Roblox APIs. There is a lot of APIs that we provide you guys. There is a lot of temptation to say, no, this API isn't good. It doesn't do what I want. Let me just write this from scratch. And some people do this, and this can work. But in general, it's less efficient. So there are examples like this when people rewrite the entire API, like people write custom animation engines. And this can work reasonably fast. But if you have a lot of characters and you try to use our animation system, you will generally find that it's more efficient. And if you're missing features from the animation system, the correct solution is to ask us for extra features, not to say, oh, yeah, I will just rebuild it myself, because why not? Same thing applies to UI layout, right? So historically, Roblox didn't have great tools to do UI layout. So people would write a lot of code that takes UI objects and say, hey, this size has changed. Let me move these other objects, et cetera, et cetera, et cetera. There is UI layout, UI constraint objects available to do this in the engine right now. If you want to do something that is complex and you find, hey, there is no layout or constraint object, for you, tell us about the problem. Maybe we can make one, right? There's like examples like this where right now we are shipping an API soon that will automatically size the objects based on their children, which if you do it yourself, it's slower, so we can do it for you. And there's like some various instance new examples that are fun. There's a big thread on this on developer forum. Encourage you to check it out. Basically, if you're trying to write wrappers around instance.new to make it more convenient to use, you might be sacrificing performance. So let's talk about building. there's this variety of choices available to you as a builder on Roblox. What do I build my levels out of? You can use terrain, you can use basic parts, you can use CSG objects, mesh parts. What do I use? How do I pick? It's not obvious, right? Especially when you consider performance as an axis. So let's talk about each of these individually. Let's talk about terrain. So the nice feature about terrain is it has peak efficiency among all of these other constructs per unit of detail, which means that if you took terrain and then like exported this and imported back as a mesh part, it will generally run slower. If you try to build terrain out of small parts and model every single rock exactly as it is, it will be slower. And it's also minimum memory cost per unit of detail. It uses voxels. It's stored really, really efficiently. We have a blog post that goes into detail around the voxel storage. So it's hard to beat that, right? And you can also update it at any point, and it's fast. So what's good about this is it's stable, guaranteed performance. What's bad about this, if you don't need this detail, then you're paying for some amount of overhead no matter what, right? So if you want a giant part and you say, hey, instead of making a giant part, I will just make giant terrain, well, it's hard for giant terrain to compete performance-wise. We try, but it's hard to beat it, right? So when you use terrain, what should you consider doing and not doing? Well, use different materials. It's the same cost, and using different materials provides more variety, so use them. Water is slightly separate, but still you should use water in general. If you want to use water, there's like no reason not to if you already use terrain, right? Use very terrain shapes. You are paying for some complexity associated with the system, so take advantage of it, right? Don't build flat terrain because you like how flat terrain looks. Players might like more varied terrain better. And there is some issues with terrain that are associated with loading time. It's a lot of voxels that you have to ship to the client. So there is a current solution which is streaming enabled. And there's a future solution which I already talked about, which is streaming LOD, where we would stream parts of terrain more efficiently at lower resolution far back. And this could keep the join times really fast, but make it so that large landscapes are available on the client really quickly. Don't just assume that terrain is going to be fast enough. Profile it, right? So measure everything. If you want to do a flight sim, and your flight sim is really big, has a really big world, well, try to generate terrain of the size that you want it to be and measure it. It might be fast enough. It might not be fast enough. I know some people who are building games like this in-house right now as part of accelerator program. They have to do tricks to make larger worlds by making the characters, etc., smaller, so that each voxel kind of occupies more space. So that can work. But in general, like, be aware, it's not a magical solution, right? And there is also one thing I want to mention that some people are really hung up on, which is, hey, I have this mountain. I only need the exterior surface of the voxels. Let me just cut everything in the middle. So you should measure this. Often, our LOD system doesn't really work super well with one voxel thin shells. You need like 4 to 8 voxels. And the other thing is, by cutting this space in the middle, you are disabling some of the optimizations that we have that expect mountains to be solid in the middle. So you might be worse off. You have to measure this. All right, so let's talk about basic parts and other parts like this. So what is basic parts? Blocks, spheres, cylinders, wedges, corner wedges, all this amazing stuff that we have supported over the years. The problem with basic parts is low efficiency per unit of detail. Like, the block is kind of boring. You have to have a lot of blocks to have varied content. The good thing is you can take a part, you can change it however you want at any point in time. Because of this cost per part, on low-end mobile, you should target like tens of thousands of parts approximately, right? Low tens, high tens, depending on whether they move. If they move, it's you are paying way more cost. Or you should use streaming, right? So it's OK to build your levels out of like hundreds of thousands of parts on low-end mobile if you use streaming and if your parts are not too dense. If you don't have one building that's built out of 10,000 parts, 100,000 parts, and instead you have the entire world that's built like this and you use streaming, is going to be OK. Otherwise, it might not be OK. So CSG parts are medium efficiency per unit of detail. I'll go a bit into this later. But it's basically our system for building CSG objects is reasonably good, but it's not perfect yet. And it doesn't allow you to control the level of detail. Some of this will be solved with LOD that we'll be rolling out this year. And mesh parts, the good thing about mesh parts is it's good efficiency per unit of detail. You can make the mesh pretty complicated, and it will run faster than most other solutions except terrain. The bad thing is you have to use an external tool It's a learning curve. I don't know how to use Blender, for example. It's really hard. So just beware of this, right? Like building content in the studio might be much, much easier. So let's talk about physics performance for a bit. So once again, basic parts, CSG mesh parts. What's the difference? So basic parts, it's kind of the same deal. It's peak physics performance if you have one big part. It's not very performant if you have a lot of small parts. There are some optimizations that are missing from this right now. We are planning to work on some of this, but fundamentally, since you can take any part and move it anywhere at any point in time, it's going to be less efficient than using something like a CSG, right? So people ask a lot about the difference between CSG and mesh parts, and the truth is they are using the exact same system underneath for both rendering and physics. The difference is what kind of data goes in, right? So when you use our CSG modeler, it creates certain number of triangles in certain shapes. And when you use Blender, you have full control. But this is what matters. It's not whether it's a CSG or mesh part. So it should be identical physics-wise, performance-wise. You should be aware that collision fidelity should be used if you have performance issues with either of them, right? So if you don't need collision, you can use box. If you do need collision, but your object is simple, like a traffic cone, use hull. Otherwise, use default, and it's going to do a convex decomposition. And we plan to improve on all of this over time, but this is kind of the current status. So the other big thing is some people want to know, hey, should I disable collision on all of my parts that I don't expect the user to collide with? And the answer is it doesn't actually help unless the user is in close proximity. So if you have a large mountain somewhere far in the distance and it's anchored and there's nothing moving around this mountain, don't bother. It doesn't matter. If you have a large mountain that's really close to a bunch of moving trains, but the trains don't actually ever fall on the mountain, it might be worthwhile to disable collision. All right, rendering. The beautiful screenshot in the bottom right is from Jailbreak. This is when we were rolling out instancing for mesh parts and accidentally broke UV mapping. Sorry, guys. So basic parts, CSG parts, mesh parts. Basic parts, use Roblox materials. You can use texture objects, but this will be less efficient. So try to use Roblox materials whenever possible. Plastic versus non-plastic matters less. Plastic is slightly faster, but all materials are reasonably fast. For CSG parts, it's the same thing. Use Roblox materials. Don't treat CSG as this magical performance fixing solution. Oh, hey, I unioned every pair of parts in my world. Surely it must become more efficient. No. It defeats instancing optimizations, and it defeats a lot of other things that we try to do internally to make your worlds run fast. So try to target like dozens of parts when you are building a union for performance. Maybe more, ideally more. So when it comes to mesh parts, you can use Roblox materials. The mesh parts give you an extra option of using texture ID. On the mesh part itself, this is also really efficient. And it's kind of the same thing. Don't treat meshes as, hey, it's a magical performance solution. One mesh part that is pretty coarse and not highly detailed is faster than one mesh part that is highly detailed. But if you have one mesh part that is at a triangle limit like 5,000, and then you split it in 5 of the same triangle complexity, like 1,000 per part, it will not run faster. It will probably run slower. So use good judgment, I guess. Transparency. So the biggest thing that you can do to make our renderer and any other real-time renderer to run slowly is use a lot of transparent objects. It's bad for many reasons. And of course, it doesn't apply if your transparency is exactly 1, at which point you are not rendering the object, and this is a really efficient path. So the most efficient path is transparency 1. The next one is transparency 0, and everything in the middle is not great. Textures and decals are really convenient, but if you say, hey, I want to cover every object in my level with textures, it's bad. It's not just bad because currently you need like 6 of them so that every side is covered. It's also bad for other fundamental performance reasons in rendering. It gets especially bad if you say, OK, I placed these textures on all of my sides. I don't want my levels to render slowly, so I will just hide the part that's at the center. Don't do this. This murders performance of mobile devices. Just don't. Some people did do this, and this is why I had to put this here. So did I answer the question? Well, no. But I gave you some information that maybe can help you answer the question for yourself. The real answer is, it's really efficient and can work really well to combine all of these in your place for different purposes. And you should measure every single thing that you do and make sure that performance is actually good. So conclusion, use our tools. Tell us when our tools don't work. Tell us when performance is bad. Try to measure everything that has to do with performance in your game. And if you don't tell us anything, then we will not get better. So talk to us. Thank you. And I think we might have a couple of minutes for questions.
Hi, I make like usually really big games, like tons of parts, tons of players, instances, all on the same server. And I noticed a lot of things you talked about seemed to be client-based. Is there any things that you've talked about, or any things coming in the future that help server performance?
A lot of the physics stuff is directly applicable to the server. The other things mostly aren't. So as we are working right now through our 200-player project, we are learning about a lot of performance pitfalls in terms of working on code in the server context with many, many players. And I think as a result of this, we will publish some guidelines and what things to do and what to not do. Out of this talk, physics is applicable. Most other things are client-side because performance is at premium on mobile, right? And servers at least have good hardware.
With the advent of mesh parts, some places have been increasing number of mesh parts in them, and this has been affecting load time, such as the game I've been working on as the whole map is about 90% mesh parts, about 500 to 1,000 individual mesh parts at one time occasionally. Is there any way to improve load time with this?
So combining mesh parts up to a polygon limit can help. Simplifying mesh parts can help, right? So simplifying the total number of triangles effectively. The other thing is we are working on some things. Each mesh part is an individual asset.
Yes.
And we are working on some things that will make loading like 100 or more assets in parallel faster. So it might get a bit faster over time. There's no magical solution necessarily other than this. If you can share your game after, we can look at your game directly and, hey, maybe there's something we can improve.
Thank you.
I had a question that doesn't really relate to physics necessarily, but it was more about like Roblox API. So like say if in an extreme example, it's about the collection service, say I have like 1,000 tags in my game or something crazy, and I'm thinking about using the collection service like has tag on an instance frequently versus just doing like find first child with like a string value or something. So I was just wondering basically what the efficiency of that service is.
Hashtag will be more efficient. It is highly optimized for moderate number of tags, but like 1,000 is okay probably. So it's generally going to be more efficient. You should not use children that don't provide functionality in place of tags. Tags will be faster.
You can't see me, but is it better to use multiple remote events or just one?
So the general rule of thumb is that multiple remote events can be better in bandwidth. This is because if you use just one, generally you have to send something else that says, what do I want to do?
Well, let's say like it's not sending like a lot, like because I have one in one of my games where it's all connected to one event, but you know a player's invoking it, you know, maybe once every like 10 seconds for 10 players.
Then it isn't truly important.
Okay, yeah.
If you have massive amounts of data, then generally more remote events is slightly better.
Okay, my question was just like, does it cause like a lot of server lag because they have to wait and listen for every event? Not really, or?
I mean, if your number is moderate, if you are talking 100,
okay.
It's okay. If you are talking, hey, I have 10,000 remote events, yeah, don't do this, do one.
Okay, thank you.
Hi, I'm building a custom terrain generator using a bunch of mesh parts that are just wedges with the sides removed. And I've noticed that the memory usage isn't really that different between having the mesh parts with the sides removed and just having normal wedges. And I'm not sure if like instancing is enabled on the wedges that are different sizes, because they're ever so slightly different sizes. Is that impacting performance?
So the general rule of thumb is if you take a part and resize it, instancing will share memory. If you take a mesh part and have a different mesh part, like you resize it in Blender or something, and re-upload, it will not share memory. The caveat is today, wedges aren't instanced yet. This is the update that we are rolling out soon, right? So the only
Yeah.
instancing is there for mesh parts. But resizing will not affect the ability to instance. Neither will color changes nor any other property, really.
All right. Thank you.
For hiding objects in workspace, which is more efficient, setting the transparency to 1 on all the objects and making it uncollidable and then reverting that when or making it visible again, or just unparenting it and then reparenting it to workspace?
So it's hard to make a definite statement. I would say that if you aren't doing this frequently, removing from workspace might be faster. It depends a bit on the use case. If, for example, if you set no can collide to false and the humanoid comes in close contact, you still are paying for physics workload. So it's not definite. I would say generally it's better to remove and insert. Sometimes, if the action is very quick, like you want to hide the object but then it reappears in a second, then it might be better to do transparency. If you are talking about custom LOD systems, then unfortunately any approaches there currently suffer some performance issues, which is why we kind of want to build a solution that works out of the box.
Hello. Earlier you mentioned how textures can require a little bit more time for than, say, regular parts without textures. Does the amount of surface covered by a texture change how much it takes?
No.
Okay, thank
It's
you.
only whether it is on each particular side.
Okay, thank you.
Just one last question. Will there be any future plans to allow players to create their own custom collision fidelity?
We have talked about this. It is likely that something like this will come as mesh parts pipeline. Maybe not CSG, but yeah, for mesh parts, there are some really important use cases where our current simplifier is not very good. The first thing is to make it better, and the second thing maybe is to allow this. So maybe, I'm not sure, but it's definitely possible.
Thank you very much. Arseny will be in the back to answer more questions.
I'm also here all day, so just come grab me at any point in time. Thank you.